In this video, we're going to do a little bit of a discovery first before just giving you the rules for this next special right triangle. So we're going to discover where they come from first. So we're going to draw in a median in this equilateral triangle. So median goes from a vertex to the midpoint. So I'm going to draw in just with a ruler here. Okay, and then this point right here is D. So we're going to label that guy D. Okay, so we're going to measure with a ruler. I'm going to use centimeters. Okay, so sorry, my little camera's in the way here. So from there to there, I'm about 4.9 or 4.8. Okay, so now if I do one of these sides, getting about 9.5, which is pretty close, okay? And then let's see, AD, it's about 8.1 or 8.2. Okay, so, and this is all in centimeters, so let's see, my BD was about 4.8, AB is about 9.5, and AD 8.2. Okay, so granted there might be some human error here, these are approximations but pretty close using centimeters. Okay, so we're gonna try and come up with an algebraic proof between the short leg, the long leg, and the hypotenuse. Okay, so we're gonna let BD be x. So this side is x. So since this is the midpoint, this side is also x. And then these three sides are all the same. So x and x, I could also think about that as 2x. Okay, so I have this triangle right here that's a right triangle. Okay, so I know that I have BD squared plus AD squared has to equal AB squared by the Pythagorean theorem. Okay? All right, so let's go ahead and plug in my x values. So BD is x, AD is my unknown, okay? And then AB is 2x. Okay, so here I have x squared plus AD squared equals, this is 2x times 2x, which is 4x squared. Okay, I'm going to get my x squareds together, so I'm going to subtract x squared from both sides. So AD squared is 3x squared. Take the square root. So I have AD equals square root of 3x squared. I can pull out the x's. So I have AD equals x times the square root of 3. Sorry, AD equals. So the relationship here is that whatever the short leg is, so whatever this leg is, if I multiply it by the square root of 3, that gives me this. So let's try it with my numbers. So I had 4.8. And if I multiply it times the square root of 3, do I get about 8.2? Ah, I was pretty close. So that tells me my measurement wasn't too terrible. And then this should be double that. I think that's close as well. Yeah, okay, so not too bad. So the formula works well with my answers. And actually, these are going to be the exact answers where I was rounding when I was measuring, just to whatever the closest tick mark was. Okay, so in short, my short leg is always x. Long leg is what we just discovered, that I can multiply that by the square root of 3. And then the hypotenuse is always double the short leg. Okay, so the short leg is always across from the smallest angle, which is 30. So this one is x times the square root of 3, and then this one is 2x. Okay? All right, so let's use this now to find some missing sides in triangles. Okay, so here they are giving me the hypotenuse. So this is equal to 2x. Okay, so if I wanted to solve for x, I would just divide by 2, right? So x is equal to 8. The short leg is always x. So this side is 8. Okay, and then the long leg is x times the square root of 3. So that would be 8 times the square root of 3. So my two sides, so I have AB is 8 and AC is 8 times the square root of 3. Okay, this one we are given the long leg. So remember the long leg is equal to x times the square root of 3. So I want to find x, so I have 12 equals x times the square root of 3. So to find x, we would divide both sides by square root of 3. Now, x equals 12 divided by square root of 3. Remember, I don't want to leave my radical on the denominator, so we're going to multiply by square root of 3 to rationalize. So this is going to become 12 times the square root of 3 over 3. 12 divided by 3 is 4, so this is going to be 4 root 3. So that is x. Okay, and then remember y, in this case the hypotenuse is double that, so y is equal to 2 times 4 root 3, which is 8 root 3. Okay, awesome. Okay, this problem says given an equilateral triangle, so this is just like the one we just found, or the discovery one, with an altitude, another word for this is height. Okay, of 15 centimeters, find the area and the perimeter of the triangle. Okay, so we have equilateral triangle, so all three of those are equal. Okay, the height is 15. So this is the long leg, right? So this is x and this is 2x. So to find this, 15 is equal to x times the square root of 3. So just like this previous problem, we're going to get x by itself, divide by root 3. So I have x equals 15 over root 3, but we're going to rationalize. So I get 15 root 3 over 3. 15 divided by 3 is 5, so x is equal to 5 root 3. So on my triangle now, this is 5 root 3. 5 root 3, and then this would be 10 root 3. It's double that, okay? So hypotenuse is always double whatever the short leg is. So for the perimeter equals 10 root 3 plus 10 root 3 plus 10 root 3, right? 1, 2, 3. So the perimeter is equal to 30 root 3. Area of a triangle, if you guys remember, is the base times the height divided by 2. So my base is this whole side, so 10 root 3 times the height over 2. 10 times 15 is 150. And 150 divided by 2 is 75. So one other thing is, in this one, this should be centimeters. And this one should be square centimeters for area. Okay, that's it for the 30, 60, 90. Thanks for watching.